Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are going to deep dive into the gradient of scalar point function. Okay, we'll see what is the gradient of the scalar point function. So ever wondered how heat spreads across a metal plate and how a ball rolls down a hill? All of that is driven by one powerful mathematical concept, the gradient of a scalar function. So let's break it down simply with real world context. Okay, what is a scalar function? You might know, like, what is a scalar function? A scalar function is something that gives you just a number at each point, right, in space. So it is giving you just a number, not a direction. If it gives you even the direction with the number, then it is something called as vector quantity or a vector function, something. But scalar is something which is giving you just a number, just the magnitude. Okay, so that is a scalar. So for example, temperature at every point in a room, you could have like 30 degrees Celsius here and 20 degrees Celsius somewhere else, right? So each point has some scalar value. So what is the gradient? Now the gradient is a vector that points in the direction of the greatest rate of increase of the scalar function. At what direction, the speed or the rate is increasing of the particular scalar function. So gradient is nothing but a vector quantity. Gradient is a vector function that points in the direction of greatest rate of increase of the scalar function. So think of it like a compass needle showing you the steepest hill climb from where you stand. So mathematically it is written as grad phi equals to, also as del phi equals to I times partial differentiation with respect to x, j times with partial differentiation with respect to y, and k times plus k times partial differentiation with respect to z of what? Of phi. It is multiplied entirely with phi. So now I'm multiplying this inside. So I'm getting dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k. So if I write this summation of what? These three are unit vectors, right? The summation of dou phi by dou x, okay, into I. This is just a last summation. So note that gradient of a scalar function is what? Vector quantity. Gradient of a scalar function is a vector quantity. And this is how it is written. So real life example I'm telling you, consider a temperature map. Okay, imagine you are holding a metal plate where different parts have different temperatures. One metal plate, and consider you're giving heat from here. Okay, this side you're giving heat, so here it will be more heated, then little bit less, then less comparatively, right? So one plate you're holding and it has different temperature at the different parts of the plate. So the gradient at any point on the plate, at any point in the plate, will point you towards the hottest nearby direction. This is the hottest according to, because I'm giving here, I'm providing some fire here, for this plate to get heated. So from here the fire is going. So it is the possible hottest nearby direction, right? So it's like heat's GPS telling you go this way for more heat, go this way for more heat, go this way for more heat. I hope it is clear. So here engineers use this model to heat transfer and even predict how machines heat up during use. Okay, so consider there is some furnace, or you're heating something, you're manufacturing something, you have some chemical factory. So if you're providing heat, how the heat is getting transferred? Okay, is it uniformly? So the base will be heated up first, then the upper layer of the furnaces and all. So that is how the engineers use this. I hope this was clear. I hope this was clear. So the gradient is silently guiding you, guides that change. Okay, whatever, this is the nearby point, or this is the fastest reaching point. So the next time you feel temperature change or whatever, that is what the gradient is silently guiding you to that change. Okay, and it's not just math; it's how the nature works. Thank you so much for watching. Just see this once again, the grad and grad phi or del phi. So this is the formula we use it mostly, to find the gradient of a scalar point function. And the gradient is what? It's a vector quantity. Gradient of a scalar function is vector quantity. Thank you so much for watching. Do not forget to hit the bell icons, share, subscribe, and put a comment if you have any doubts.